Hello and welcome to Science Lesson 4. Which method speeds up the drying of clothes the fastest? Pause the screen and get someone to write something to write with and write on. Okay, let's begin. So we're going to start with our knowing more, remembering more, as we always do. So, water is a gas, true or false? Pause the screen. Which of these is not a state of matter? Solid, melt, liquid, or gas? Pause the screen. How can you turn a chocolate bar into a liquid? Pause the screen. Which material is a good conductor of electricity? Pause the screen. Okay, let's see how you did. Water is a gas, true or false? It is in fact false. We know that water is a liquid. Of course we do. Which of these is not a state of matter? We know solid, we know liquid, and we know gas. So that means it is melt. How can you turn a chocolate bar into a liquid? If you add enough heat to chocolate, it will melt into a liquid. And finally, which material is a good conductor of electricity? And the answer is metals. So your success criteria for today. I can define evaporation. I can investigate conditions that speed up evaporation. And I can explain what factors speed up evaporation. And you have your keywords, my turn, your turn, evaporation, boiling. All right, so let's recap what is happening in each picture. We have an ice cube there, and we have a pot of water, and we have a tray of ice cubes, and we have a sandwich. What's happening? Pause the screen. Okay, so with the ice cube at the top left-hand corner, you have the ice cube and it's melting. So the ice cube is changing states from a solid to a liquid. You have the pot of water that is boiling. So the water is changing states from a liquid to a gas. The bottom left, you have a tray of ice and the water has changed state from a liquid, which was the water, into ice. Okay, so from a liquid to a solid. And finally, you have the toasted cheese sandwich. Looks delicious. So the cheese has changed its state into from a solid to a liquid. Some lovely, delicious oozing cheese. So let's recap. What are the 4 changes of states? Do you remember? Pause the screen and have a go. So the 4 changes of states are melt, boil, condense, and freeze. Drying clothes. What happens when we dry clothes on the washing line? So remember, when we take the clothes out of the washing machine, the clothes are wet. When we put them on the washing line, we want them to dry. When we come back a little while later, the clothes are dry. So what happens? Is it A, we change from solid to a liquid, B, from liquid to gas, C, from gas to a liquid, or D, from liquid to a solid? Pause the screen and have a think. Let's see if you are right. So we change states from liquid to a gas. What change of state is this? It's boil, isn't it? Do we see our clothes boil on the washing line? No, we don't. Boiling occurs when all of the liquid is at the boiling point. So when water boils, every water particle is at what temperature? That's right, it's 100 degrees. Thinking about a puddle disappearing after a day or two, did the water boil away? Was it ever 100 degrees outside? I don't think I've ever seen a puddle boil. The water hasn't boiled, it has evaporated. Let's look at this in more detail. Evaporation is when a liquid turns into a gas, but it's different to boiling. The water doesn't need to reach 100 degrees. The particles on the surface just need to have enough energy to change state and escape. The water in a puddle seems to disappear, does it? No, the water changes from water to water vapor, and we can't see water vapor because it's invisible. The particles are very tiny. The same thing happens when clothes dry. The water particles on the surface get hot enough to change state and escape. Is this a fast or slow process in comparison to boiling? Here we have a definition of evaporation. Evaporation happens when particles on the surface of a liquid get enough energy to change from a to a. An example of this is when particles evaporate from the of puddles. You have a word bank here. What you need to do is you need to write this definition in your books and use the word bank vocabulary to put in the gaps. Pause the screen and do that now. Okay, let's see how you did. So evaporation happens when particles on the surface of a liquid get enough energy to change state from a liquid to a gas. An example of this is when water particles evaporate from the surface of puddles. Now, Mr. Wrong always gets things wrong. Can you correct the mistake in each of these sentences about boiling and evaporation? So let's do them one at a time. Number 1, evaporation and boiling are the same thing. What's incorrect about this statement? Pause the screen. So, evaporation and boiling are actually different, aren't they? Number 2, evaporation occurs at the bottom of the liquid. What's wrong here? Pause the screen. Here, we know that evaporation occurs at the surface of the liquid. If we think about the puddle, the particles evaporate from the surface, okay? Number 3, boiling happens when all the particles are at the melting point. Boiling happens when all the particles are at the melting point. What's wrong here? Pause the screen. Okay, so actually boiling happens when all the particles are at the boiling point. Number 4, the boiling point of water is 0 degrees. What's wrong here? Pause the screen. Actually, the boiling point of water is 100 degrees. Number 5, for evaporation to occur, it has to be 100 degrees. For evaporation to occur, it has to be 100 degrees. What's wrong here? Pause the screen. Well, actually, for evaporation to occur, it doesn't have to be 100 degrees. It just has to be warm enough for the particles to evaporate. So here we can tick off our first success criteria, which is I can define evaporation. Well done. So let's do an investigation. How can I dry my clothes faster after washing them? Using the equipment below, how might you investigate this question? You have a fan, a heat source, water, squares of material, and a stopwatch. So you can do this at home. Ask an adult for help. Do not put water near electricity. First, soak 3 pieces of kitchen paper water and wring out the excess so it is not dripping. Place 1 piece of material somewhere warm, like an airing cupboard or radiator. 3, dry 1 piece of material with a hairdryer on cold setting if you have one. 4, place 1 piece of material outside on a washing line if you have one, or on a windowsill. 5, set the timer going for 5 minutes. And 6, collect your 3 samples. I need you to make a prediction. Which conditions do you think will make the material dry the fastest? So do you think the material in the airing cupboard will dry fastest, or maybe the hairdryer will dry fastest, or the material on the washing line? Which one? So you need to write this down in your book. I predict that the material that is will dry the fastest because. So you need to also explain why you have made that prediction. Do that now, pause the screen. So what we're going to do is we're going to watch a video of this experiment.
Hello everyone. Today we are going to look at which conditions help dry material fastest. Now you can see the stopwatch going. That is because I've already set up my experiment because I want to see the results at 5 minutes. So I'm going to explain what I did. First of all, I got a piece of kitchen towel. I'm sure you might have one at home. And I cut it into, because mine was quite a large sheet, I cut it into quarters because we don't need much material for this. I then dunked the kitchen towel in some water. I then squeezed out, because what I don't want is it really dripping wet. I want it damp. And I then opened it back out very carefully, trying not to rip it. And I placed the kitchen towel, in my case, over a boiling tube rack or a test tube rack. This is just so that it had more surface area that was exposed to the conditions. You could use any thing you like. You could use a piece of string. I then place them in 3 different areas. I have one in an open window. I have one on top of a warm radiator, not a really hot one, but a warm radiator. And I have one in front of a fan like this. And we are going to leave our experiment for 5 minutes to see which one dried the best in which, or the fastest in which conditions. While we're waiting for those 5 minutes to be up, I would like you to make a prediction. Which do you think will have dried the best? Is it the one in front of the fan, the one on a slightly warm radiator, or the one in the open window? Which one do you think will have dried the least? Please make a prediction and explain why you think that. Write your prediction on your sheet. In your prediction, can you also explain what is happening to the water? Where is it going? What process is it going through? So hopefully you've written down that the water is evaporating from the material, turning from a liquid into water vapor or gas. What prediction have you written and what reason have you given for that prediction? Our timer is coming up to 4 minutes now, so we've got 1 more minute. And then what we will do is we will compare the kitchen towel and see which one has dried the most and which one has dried the least, so that you can use those observations to write a conclusion. If you are doing this at home, make sure, please, that you have not put dripping water or any water near an electrical source. You shouldn't have done, because you should have put it in near an open window. You might not have had a fan. You could use a cold hairdryer. If you're going to do that, please make sure that you ask a parent for help with that. Okay, so 5 minutes is up, and let's see what our results are. So this one is our one in front of the fan. The middle one was in front of the radiator, and this one was on the open window. So let's have a look. In fact, if you look carefully at the colour, I don't know whether it's clear to you, but these ones are a bit lighter. They're a bit lighter because there is less water absorbed into the material, which means the water has evaporated. Let's see when I crunch them up. This one's the one that was on the open window. If I squeeze that hard, I am actually getting water droplets. I don't know whether you can see that. So that one hasn't dried well at all in the open window. These two, however, I would say were pretty much equal. If I squeeze them both, no water is coming out anymore. And as we made our observations before, they're both slightly lighter in colour because the water has evaporated. Using those observations, write your conclusion on your sheet.
So, within your conclusion, you need to answer the following questions. Which square of metal dried the fastest? Which square of metal dried the slowest? And what factors did you find sped up evaporation? Pause the screen. So now we can tick off our second success criteria. I can investigate conditions that speed up evaporation. Well done. So what factors speed up the process of evaporation? We have already talked about air movement and heat. Increased air movement, the speed of evaporation. Increased temperature, the speed of evaporation. What should go in the space? So increased air movement increases the speed of evaporation, and increased temperature increases the speed of evaporation. What about these two situations? Which will dry faster? Why? So you have a towel on the floor bunched up, and you have a towel that is hung up. Which one will dry faster and why? Pause the screen. So the hung towel has a larger surface, so water will evaporate faster. Did you get that right? So now we can tick off our third success criteria. I can explain what factors speed up evaporation. So, reviewing the knowledge, what I want you to do is I want you to now go over to Purple Mash and complete the quiz in your to-do for science this week to test your knowledge. Thank you, and I'll see you next week for your 5th science lesson.